Hey, good morning, good afternoon, good evening, or whatever is going on where you are. Welcome to what's going to be probably one of the shortest lessons we're going to have this semester. Today, we're going to be talking about normal lines. Now, in case anybody's curious, what is a normal line? Basically, you know how to find the tangent line now? Well, the normal line is going to be perpendicular to the tangent line at that same point of tangency. So how do we go about doing something like this? Well, what we're going to do is we're going to take an example. And again, freeze this. Again, the normal line is just going to be perpendicular to the tangent line. Again, if you're in physics, they might have used the word orthogonal, but that's just another fancy word. All right, so let's take a look at this particular example, which will be right coming up here. What I am looking for is I am looking for a way to write an equation for the normal line to the given curve, f of x equals 4 minus x squared at x equals 1. And because the pen features on this particular software are not as good, I'm going to switch out and go into smart stuff. So let's get going on this. It says find the equation for a line that is normal to the curve. Okay, so in order to get there, I'm actually going to take the time to find the tangent line, or at least the setup to find the tangent line, and then we're going to keep going from there. So let's go ahead and do this. And remember, what we're looking at is we're looking at the limit as h approaches 0 of, let's see, I'm going to say, in this case, I'm actually just going to substitute in the x equals 1. So I'm going to say it's going to be f of 1 plus h. So I'm looking at 4 minus the quantity of 1 plus h, quantity squared, minus f of 1. Well, when I substitute 1 in there, I'm going to be looking at 3 all over h. Okay, so far so good. Let me see what I can do about trying to expand this loveliness. So we're next looking at the limit as h approaches 0. I've got 4, and then I need to use the FOIL technique or the double distributive, whatever, to get that we're looking at 1 squared plus 1h plus 1h, which is going to get me 2h plus h squared minus 3 over h. And going to keep rolling on this. And let's change colors because it's getting boring. Okay, the limit as h approaches 0 of 4 minus 1 minus 2h minus h squared minus 3 all over h. Okay, at this point, I am now going to try and make stuff clean up. So I'm going to say 4 minus 1 minus 3 is going to get me a grand total of 0. And so now I'm looking at the limit as h approaches 0 of, let's say, negative 2h minus h squared all over h, which I could look at this expression and just say that that's going to be the limit as h approaches 0 of h times negative 2 minus h all over h. And at this point, I'm going to cancel my h's. I'm going to directly substitute that in there, and I'm going to be looking at a value of negative 2 there. Okay, so that tells me the slope of the tangent line. I'm not looking for the tangent line. I am looking for the normal line. So what do I need to do to find something that is perpendicular to my tangent line? I'm going to say in this case, well, that's just going to get me opposite reciprocal. How about 1/2 there? Okay, so that's my slope. Now what do I do? Well, I still need to figure out what the corresponding y-coordinate is way back at the beginning when I was looking at when x equals 1. So now I have my point. I can say I'm looking at the point 1, comma, substitute 1 in there, and I'm going to be looking at 3. So I now have my point, I have my slope, and I'm ready to use my point slope formula to say x minus 3 equals 1/2 times x minus 1. Okay, let me see if I can get back into this other format. And I'm going to say that if I'm asked to clean this up, I really could if I wanted to, but for our purposes, I don't need to. But let's just say we ran into, I don't know, some crazy multiple choice section. So I'm going to distribute that 1/2 there. It's going to be minus 1/2. And my picture is getting in the way. So let's move it up here. And then I'm going to take and say that's going to be 3 minus 1/2, which is going to be 2/2. I'm sorry, 2.5, or to have it as an improper fraction, I'm looking at 5/2. So I will tell you, if you get to there, I'm happy as a clam in sand on any assessment. But on the multiple choice section, they could ask you to go and be able to identify it all the way down to 5/2. Which is why back on the original screen, it probably gives me an answer of, oh, look, just like I said, my answer is 5/2. So, and of course, once this display goes away, you should be able to see that it's going to be 1/2 x plus 5/2. Okay, folks, that's it for today. Go ahead and get to work, and I'll look forward to seeing you guys a little bit later on in class. Bye.